There is a treaty that has held the world together for nearly 60 years. It is called the Outer Space Treaty of 1967. It is one of the few things the entire human race actually agrees on. And Article 4 is very clear. You cannot, under any circumstances, place nuclear weapons in orbit or in celestial bodies. But 4 days ago, inside a conference room at the American Geophysical Union, a group of NASA engineers and planetary defense experts started a conversation that might force us to rip that treaty up. Because we have a problem. It is arriving in exactly 7 years. And for the first time in history, the only logical solution might be to launch a nuclear warhead into the dark. On December 17, NASA engineer Brent Barbee walked onto a stage and dropped a bombshell update regarding Asteroid 2024 YR4. Now, if you follow this channel or even just read the news, you know this rock. Last year, it was the nightmare scenario. The models showed a terrifying probability of it hitting Earth. Then, the data improved, the path was refined, and the headline changed. It was going to miss us. We all moved on. But here's the thing about orbital mechanics. Missing Earth does not mean missing everything. The new calculations presented at the meeting confirm that, while Earth is safe, the Moon is in serious trouble. There is now a confirmed 4% chance, that is 1 in 25, that this asteroid will slam directly into the lunar surface on December 22nd, 2032. In the world of probability, 4% is huge. If you had a 1 in 25 chance of dying every time you started your car, you would never drive again. But why does this matter to us? The Moon gets hit all the time. It is covered in craters. It is a dead rock. Let it take the hit, right? That was the assumption, until the experts at the meeting laid out the physics of what happens next. See, when a meteorite hits Earth, our atmosphere acts like a shield. It burns up the small stuff, and for the big stuff, the air pressure holds the explosion down. The Moon has no atmosphere. It is a vacuum. So when asteroid 2024 YR4, which is a solid rock the size of a 15-story building, hits the Moon at 30,000 miles per hour, it won't just make a hole, it will create a kinetic splash. The technical term for what comes next is retrograde debris injection. Because there is no air to slow it down, the impact will blast millions of tons of lunar soil, razor-sharp dust, and boulders upward at hypersonic speeds. The models show that this shotgun blast of debris won't just fall back into the crater, it will escape the Moon's gravity. And gravity is going to pull that cloud of shrapnel right toward us. We wouldn't be facing an extinction event, we would be facing a blinding event. That debris field would tear through the orbital lanes where we keep our GPS satellites, our weather monitoring systems, and the International Space Station. It creates a risk of Kessler syndrome, a chain reaction of collisions that could destroy our ability to leave the planet for a generation. Suddenly, saving the Moon isn't about sentimentality, it is about self-preservation. And this is where the conversation at the AGU meeting shifted from observation to intervention. The engineers were blunt. For this specific rock, on this specific timeline, our usual tricks won't work. We can't just crash a spacecraft into it like we did with the DART mission a few years ago. That works for small nudges on slow rocks. This asteroid is coming in too fast and the window to act is too short. That leaves us with the nuclear option. Now pause for a second. Get the movie Armageddon out of your head. We are not talking about sending drillers to the surface to plant a bomb. That is scientifically ridiculous. The real plan, the engineering plan, is much more elegant. It is called a standoff detonation. The proposal is to launch a nuclear device to intercept the asteroid while it is still deep in space. The bomb would detonate a few hundred meters away from the rock. In space, a nuclear explosion doesn't create a shockwave because there is no air to push. Instead, it releases a massive instantaneous flood of X-rays and neutrons. When that radiation hits the side of the asteroid, it superheats the rock in a fraction of a second. A thin layer of the asteroid's surface instantly vaporizes. That vapor expands explosively into the vacuum, acting like a rocket engine. It gives the asteroid a massive, violent shove in the opposite direction. It is a nuclear-powered kick. And according to the math presented by Barbee and his team, it is the only method that packs enough energy density to guarantee we move this rock fast enough to save the Moon. But this brings us to the uncomfortable reality of the situation. To make this happen, we need to start building this mission now. A launch window would need to be targeted between 2029 and 2031. Think about the geopolitics of that. Imagine the United States or any nation announcing they are putting a high-yield nuclear weapon on top of a rocket and pointing it at the sky. In a world where trust is at an all-time low, how do you convince China or Russia that this is for planetary defense and not a disguised orbital weapon? And then there is the risk of failure. Let's play the skeptic for a moment. What if we launch and the guidance system fails? What if we detonate, but instead of pushing the asteroid, we shatter it? Now, instead of one bullet hitting the moon, you have 1,000 radioactive bullets. Is a 4% risk enough to justify opening the nuclear Pandora's box in space? Most people would say no. They would say, wait until the risk is 100%. But by then, it is too late to launch. That is the paradox of planetary defense. You have to act before you are certain. But let's assume we do nothing. Let's assume the treaty holds, the politics stall, and we decide to roll the dice. We have historical precedent for what happens when we just watch. In 1994, humanity watched the Shoemaker-Levy 9 comet slam into Jupiter. It left scars on the gas giant the size of Earth. It was a wake-up call that the solar system is a violent place. If we don't act, and if that 1 in 25 chance comes up, mark your calendar for December 22nd, 2032. The impact time is 1510 UTC. If you are in Hawaii or the American West, it will be night. You won't need a telescope. You can just walk out to your porch and look up. You will see a flash on the moon, a brilliant, silent spark of light visible to the naked eye, burning for a few seconds as the kinetic energy of 6 million tons of TNT is released into the lunar crust. It will be a moment of awe. You will be watching geology happen in real time. A new crater, roughly a kilometer wide, being born right in front of you. But that beauty will be deceptive, because moments later, the data will start coming in. The tracking stations will pick up the plume, and we will realize that the safe distance of space just got bridged by a cloud of rock moving faster than a bullet. We live in a shooting gallery. We always have. We just got comfortable because for the last few million years, the moon has been taking the hits for us without complaint. But shields eventually break, and sometimes the shrapnel from the shield is just as dangerous as the arrow itself. So we are left with a choice that feels like science fiction, but is actually very real politics. Do we trust the 96% chance that we are safe? Or do we break our own treaties, build the bomb, and decide that for the first time in human history, we are going to actively rearrange the solar system to suit our needs? Because the asteroid is coming. The only variable left is us. Want more stories about the things lurking in the dark that might change our history? The universe is full of them, and most of them don't come with a 7-year warning.